Okay. Ciao. Hola. I'm Matteo Collina, at Matteo Collina on Twitter. So please follow me, whatever, ask me question, interact. I reply most of the time, so check it out. I work for a company called Nearfirm. We are an Irish-based company. We help we are a professional services company. We help other companies deploy, manage, whatever, Node.js and JavaScript application in production. We also do React. We do all the things that you can imagine. So I'm here today to talk about taking your Node.js HTTP server to ludicrous speed. Yeah, you know, ludicrous speed is from Spaceball, okay? And you know, if you haven't seen this movie, you should really watch it. It's fantastic. Note that after this scene, it ends up pretty badly. So you might get in trouble. You might want to, light speed is too slow, and we'll have to go right to ludicrous speed. However, like this is not. It can end badly if you don't do it correctly. I've done it several times, and I don't know. At some point, I tried to pack up my knowledge about doing this with Node.js. So let's get started. So first of all, Ryan Dahl a long time ago introduced Node.js with an example that looked a lot like this. And you can Node.js has this barebone HTTP server, and it just does very little for you. Note that I'm part of the Node.js technical steering committee, so I end up maintaining a bunch of this stuff. You can do a lot of stuff just with Node core. However, most of you will in fact use a framework like Express. And you might want to do this. Note that if you want to go any fast, you need to disable etag and disable it's powered by. Otherwise, you don't get any performance out of Express. So especially disable etag, it's very important. The question is, like, if you want to go to ludicrous speed, first of all, you need to measure stuff. And some time ago, I ended up writing a thing called Autocannon, which is an HTTP 1.1 load tester. Now, how do you use it? Well, the way you use it, I hope all of you see this. So what you do is you do Autocannon, and you specify a number of connection, a number of seconds, and then you specify, you can use this magical flag and pass on port, and then pass a Node.js server and automatically runs it for you, and it does some load testing. And it's loading up, and it spits out some nice data. Note that I am working on doing this on a crappy MacBook, so numbers are really slow here. If you try it on a server, you will get something double that amount. This is on Node 10. So this is how you use Autocannon. Now, when you're doing things, you want to measure also Express, right? And you get this type of results. And you kind of ask the question of where did it go? Like, you use Express, and you do the same thing with Express and the same thing with your server, with Node Core, and it halves. Like, I was a little bit puzzled at some point. And, I started a journey to understand where did it go. Now, this was back in 2016, and back in 2016, there weren't many tools to do this. In fact, when you want to debug a performance problem, you might want to follow this type of path. First of all, you set up you have a performance issue in production, you set up some diagnostics to know what's going on, and fast forward, you go into reproduce it to your laptop, you create a minimal test case. However, after that, in 2016, I was I was sitting at my desk for a very long time, or walked my dog to get a little bit of a fresh, mindset on this. And, walking the dog is actually very effective, okay? Try this. Solving performance problems as walking the dog, I'm paid to walk the dog. And after that, you get a performance application. Like I looked a lot at screens that looked like the metrics back in those days. Now, at this point in time, In fact, we have something better. We have built something better at Nearform. Basically, they call it Matteo in a box. It's called NotClinic. It's my team that is building this tool. It's a suite of node performance tool, clinicjs.org. This is not in the slide. I should have put it there. Whatever. It's a suite of tools to diagnose performance issues in production. So how do you use this? Well, what you do is, for example, instead of using Autocannon, you can use Clinic. Flame is one of the tools. We have Doctor, we have BubbleProf. Check out the website, clinicjs.org. And you can say, for example, Autocannon. You pass the same parameters, and yay. And then hopefully it will work. Demo gods. This talk has some demos. So demo gods might not be with me from time to time. So what you do is you get this type of things, and you run your load tests. Then it does some analysis, and then it generates a visualization. Now this is, oh, yeah, I should have done something different. Like we have a presentation mode. That's probably better to see on the screen. So you can see that, it shows exactly what is the main bottleneck of your application if it's in your application. We have another tool called BubbleProf to diagnose asynchronous actions. And it says that the bottleneck here is on this method called clear buffer on Node.js streams. How many of you like Node.js streams? Somebody. There is somebody that I can call them a masochist, probably. I maintain Node.js streams, so I can definitely say this. We can change much of the stuff, mainly because we will break Node.js so badly. But if you have any questions about Node.js streams, we can help. I can help, and let me ask question, tweet to me. Note that, in fact, with this tool, it says that if I optimize clear buffer, I get more performance out of Node Core. So, hey, good work. So, let me see if I can do this. What was the key? Yay. So, should be like this. Yay, fantastic. Okay, so this is the result for Node Core. However, we can check also with Express, and if we open it up with Express, if we do it up with Express, you can see that in fact Express is doing a bunch of other stuff, okay? And you can see there is a lot more that Express is doing that it's actually, there is a lot of work that Express is doing that you wouldn't expect. And you can see, oh, okay, so maybe it's good that, so maybe that I know where it's spending its time. Yeah. So how do you get fast? How do you implement something that is fast? Well, I call it benchmarking-driven development. So you start from scratch most of the time. That's the best way to write something fast. And then you add a feature, right? Then after a feature, you measure that feature. And after you have measured that feature, you are you optimize until there is no overhead anymore, so that it doesn't impact your benchmarks. So, and then you go to 1, you go to 2, and you add 1 more features. And fast forward 2 years, you get a web framework, okay? So possibly don't try this at home. It took way longer than expected. The first question that we asked is that, can we speed up core? Can we beat Node Core at this game? Can we get faster? Now, we have been trying to build something that serves JSON and serves JSON data. And JSON stringify is a kind of an expensive operation. So, first of all, it's a recursive function. Because you don't have, it doesn't know the structure of your thing, so you need to traverse all your objects. And you can only do this recursively. And, even if it's implemented in V8, it seems kind of unbeatable, but we beat it. How? Well, this code is kind of generic. It needs to traverse, be able to handle all types and everything. However, we were able to double the performance of JSON stringify on a complex data structure. Now, this is a very big problem on any engine that, anything that is serving JSON. So imagine that you are building a microservices system and you're moving JSON around, you're going to serialize your data structure a lot. So this can be very handy, fast JSON stringify. and check it out. How does it work? Well, you can't beat JSON stringify, right? I said this 3 times now. You can't beat JSON stringify. So there is a catch. I'm cheating, as usual. It's a schema-based JSON stringifier. So basically, I am taking, instead of writing something that is generic for any piece of software, for any data structure, in fact, it's schema-based. So it knows about what is going to serialize. How does it? It uses JSON schema. So it actually go and generate a custom stringify function for your data structure. So in that moment, it's not a recursive algorithm anymore. It can be implemented with a nice set of loops and function calls. And it's actually it's safe to use, and it's safe to use even though it uses new function. Everybody, I told you, do not ever use new function. Don't ever use new function if you don't know what you're doing. It's safe because you are actually defining your schema ahead of time with no user input. So if you use them with user input, then you are in trouble and need to be way more careful. But in this case, we are using it when we write our system, so it's fine. How do you use it? Well, you use it in combination with this nice tiny other module called flatstr. It does some magical trick on the strings, so it actually speeds up some of the internal representation of Node.js. It flattens the strings. It's a little bit complex, so check it out in a module. I would recommend you check it out. And basically, after this, you use this function and to stringify, and you can beat it just slightly. On Node 8 and 6, it was actually double, but they optimized JSON after we did this. They optimized the JSON stringify even more. So sorry. After this, we said, well, we need an HTTP router, right? So there is this router called Find My Way, written by my friend Thomas. And it's actually extremely performant. Thomas is the other author of Fastify, the other lead maintainer of Fastify. Now, this HTTP router completely avoids closure allocation. And it's built on what is called the radix prefix tree, which is a very complex data structure. I'm not going to explain how that works because it's probably a talk of like maybe 20 to 30 minutes just to explain how that works. However, it's basically, it creates a tree of all your routes. And with this big tree, it actually traverses the tree with a depth-first search, and it actually end up into what exactly you want to render. It's actually very safe to use as well. Note that the benchmarks for this are a little bit obscene. It's like, I don't know, if you're working in this type of stuff, it's kind of good. How do you use it? Well, you specify it. You specify it in this way, and then you add some routes with get, and you got the request, the response, and the parameters, and yeah, it's fine. It's done. Still, we haven't lost any performance and throughput. So the routing is a very expensive operation. Note that the way expressed that the routing, it actually degrades performance over time as many routes you add. With the Find My Way, it does not, because it creates a big tree. So good. So on top of these two things, we built Fastify. Fastify is a web framework. So how does this fare? Well, it works more or less like the other ones. Note that you can use async. Do you like async await? Yeah. Yay! Okay, yes. Do not use promises, by the way. Use async await. You can make such a huge mess using promises. So please use async await as much as you can. Note that we support async await out of the box, and you can actually just return a JSON, and it will automatically be rendered. Note that you can actually specify a full schema like this for to trigger fast JSON stringify super speed. So how do we do it? Well, we haven't lost a dime compared to the previous benchmarks and compared to Node Core. So we are still like a little bit top of the marks. And no, it's actually pretty good. So let's open up a flame graph, okay? Like flame graphs are great to see the problem. Now you can see here that it's very, very similar to the one in Node Core. There's not much difference. And there is some bit and bobs that are different. Like there is this lookup thingy here, and there is a root handler, there is which is still Fastify, there is reply send, but most of the time is still spent in clear buffer, which is Node core, and it's my job to optimize, but it's probably very hard, like really hard. I've tried doing that several times, didn't manage. So here you go. That is really cool. Where is it? Okay, here we go. So note that this is Node core and is actually very, very similar. So this is kind of a feature comparison table between Express, Hapi, and Fastify. There is other frameworks. There is Koa. There is whatever. So you can check them out yourself. We have the router, middleware, plugins, validation, of course. It's all based on JSON schema, the validation system. We'll talk a little bit more about later. We have hooks. Fastify as a lifecycle mode. It doesn't rely too much on middlewares, but we support middlewares as well. And more importantly, we support async await natively, which is actually very important. In 2018 and 2019, you want to use a web framework in Node.js that supports async await out of the box. It's very, very important. Otherwise, if you will end up using async await anyway, and if it doesn't support it, you can end up in some big problematic areas. How does it work? Well, Fastify works with this generic principle. So when you initialize a Fastify application, we do much of the work ahead of time. We do very, very little at runtime for each request. And this is the major trick. We create extremely fast data structures so that we can actually speed up every part of the system. So it's actually very good. Well, I did, all of this is based on some of the concept on an old talk of mine back in 2015. I did this talk in Portland called Reaching Ludicrous Speed. And this is kind of one of the follow-ups for that idea. And in that talk, I was talking about closures. And because going fast most of the time, it's related to this problem. Note that in this type of things, you create a closure here, okay? You create some closures. And this big data object, it's a very big object, okay? Very, very big. Now, the big problem is that this big data that I'm using just to call here, in fact, it's being kept alive up until this thing has finished. Now, if you repeat all of this for all the part of your application, you are creating a lot of, but note that this is not used, right? It's not used at all, but it's still being kept around. What does this mean? Well, this means that you are creating more work for the garbage collection, for the garbage collector. So one trick, if you want to make software fast, is to actually deallocate things as soon as possible. So how do you do it? Well, you do it in this way. So you call big data, and then it exists in this scope, but you call something else, you call the other function. But now, here is not used anymore. So I've removed one step. But I can do it even better. You can null the variable and stuff. One of the things that the key underpinning of Fastify is that we have managed our state so well to, in fact, maintain the minimum amount of state that we need at every given time. So basically, we let a lot of things be garbage collected as soon as possible, which is actually very, very good. Also, Fastify logs with Pino. I hope you love Pino. There is some nice talk. The cost of logging, it's actually probably one of my best talk. I did it with my colleague, David Mark Clemens. We wrote Pino together, then other people started helping out. And it's the fastest logging library for Node.js. Logging can be such a big burden. If you're using a major logging library, you can be quite surprised, and you're logging a lot, you can be quite surprised on the difference in throughput just by changing your logging library. Also, Fastify consumes middlewares, basic middlewares, connect middlewares, if you are familiar with the concept, okay? Middlewares that does not use like Express-specific functionality, but the middlewares that you can use with Restify, Express, Connect, and a lot of things, okay? The more common ones. And all of this is powered by this tiny library called MIDI. And
yeah, Fastify is a little bit better at Express at doing middlewares. How? Well, basically because we manage state a little bit more carefully, and it's actually pretty cool. So how do you do it? Well, this is, as I said, a nice flame graph, and this is the Express flame graph, okay, for middlewares, for a very common middleware suite called Helmet. If you're using Express or you're not using Helmet for a public exposed web application, you're doing it wrong. So you have this in any case in your app. And, it is this. Look at how big this is. Note how many calls there are there, okay? Like, there are so many calls happening, and it's really, really heavy. And, most of the stuff, like, next, there is a lot of work happening in here. And, how do you optimize it? Well, you can speed things up a little bit. So here we go, okay? So, and this is Fastify. And note that there is still a little bit of work happening, okay? But it's way smaller. The big tower is way smaller. And it's an acceptable trade-off, okay? Note that this adds overhead. So any feature you add to your application adds overhead. And that's fine, it's expected. Still, my main bottleneck is still clear buffer, so I'm good. Note that you can move to the second. Ooh, I did click somewhere. Hey, yeah. Don't worry. Here we go. Okay. So also, Fastify has some nice validation supports validating data using JSON schema. JSON schema, you probably know JSON schema, or if you don't, check it out. It's a standard for specifying data format in JSON. And we use a library called AJV, mainly because it's the more correct and it's one of the fastest ones. And it has more features, is up to date with the new version of the JSON schema spec, and so on and so forth. It's actually very nice, so check it out. However, fast is not everything, because you can, if you write your big app without thinking about other features like developer experience or the speed, the easiness of developing features and stuff, then you get into a big problem, right? So what you want to do, you want to write a framework. We wanted to write a framework that was very extensible and very easy to use. So in fact, everything in Fastify is a plugin. The framework itself provides very little. What it provides you, it's a very extensible plugin system. And we go through this in a second. So in fact, everything that could be a plugin should be a plugin. That's one of our core ideas. What we do in plugins, well, in plugins, we can define the plugins. You can also use an async function over here. And you have register to register sub-plugins. You can add some hooks for lifecycle. So you can interact, for example, when a request is coming in, or add an handler before, add a function to execute before an handler or after an handler, or what in case of errors, when the application is shutting down, whatever, a lot of things. You can also add decorators, and there are decorators for the main Fastify instance, but also for the request and reply objects. And you can add all the routes you want, also with shorthands, like get, post, whatever you are friendly with. Now, this is a typical system built on Fastify, where you have an entry point application and then multiple plugins all over the place. Plugins are really, really cool in Fastify, and it's actually how things should be implemented. So what you do is, with a plugin, in fact, you can also use decorate. And with decorate, you can actually expose a functionality from one plugin to another, only descending. So you can only see plugins descend. You can only expose something to the sub-plugins. How do you expose it to the parent? Well, how do you do this? How do you expose it to the parent? You can use a thing called Fastify plugin. And with Fastify plugin, you can actually expose it to the parent, so that you can escape the plugin jail. Every plugin is fully encapsulated. Anything that you add inside a plugin stays within that plugin. This is very nice because it allows you to take a full plugin tree and then take, oh, now I want to deploy this on an external application. So I want to move my monolith from being a monolith to being a microservice system. So I can take some of my plugins and move them somewhere else and deploy them separately, so that maybe I can scale them independently. That is a very cool feature. So we wanted to be able to do this. And in fact, a typical system, it's actually built in this way. So you have an entry point, you have an user service, maybe an event service and the ticket servers, and there is a database connector that uses Fastify plugin that is connected to the entry point, and then it's shared throughout the full system. Note that the plugins can be fully encapsulated, and there are this nice thing called prefix. So let's imagine that you have two versions of your APIs that are completely different. This is very common. So what you can do, you can mount them on a given prefix, and all the routes will be, that prefix will be added to all your routes. Note that you can even specify two different log levels for the plugins, because it's fully integrated with Pinot, so it actually creates two different log levels for two parts of the systems, which is actually a very handy feature. For example, if you don't want to see the logs for your health checks or some of your internal APIs or management systems. So it's kind of cool. Check out Fastify, and it's fastify.io. It's over there. We should have some time for a demo. So, okay, let's hope the demo gods are with me. I don't know how many of you tried to did a demo on stage. You probably know this. Can go well, can go wrong. You never know. So we are actually doing it right now. So what you can do with Fastify is you can create your little server. And always remember to put use strict at the top of every file. And then you create a nice Fastify. You require Fastify. And ooh, I can type today. Okay, and then you create your app. And yay. And you can pass logger through to have, to start logging things. And you can do, for example, get JSON. And you can use an async function here. So with request and reply. And these are our own objects. These are not node cores. And you can return a nice JSON. Here we go. And then you can just call up listen. And let's see how this fares. So we can do node server, and then we can curl it. And you can see there is a bunch of stuff because this is 404. However, we can also call a JSON, and we get our JSON endpoint. So we see a bunch of logs at the top. However, this is definitely not enough. First of all, we want to add helmet, because I told you need this module, so you need to do this. So we just add helmet, so Fastify helmet, and we do node server, and you do curl and -v, and you can see all those nice little headers that are being thrown in your server by helmet. Okay, so yeah, we have done this. Nice. Next feature on is the plugin system. Actually, next feature on is the plugin system. So with the plugin system, what you can do is you can create a new folder called subsystem and an index file in it. Now, in this index file, you can actually, as always, put all use strict in it. What you do is every Fastify plugin as this signature. So you take the application and the options, and then you can specify, for example, / our root here, and we can keep using our async functions, and we can return, for example, hello from plugin.
Matteo, I think you forgot the arrow.
Oh yeah, I did forget the arrow. Thank you.
You're welcome.
So you see, demogods. And now what you do here, it's you do app register on your plugin. Now, what you need to specify, otherwise you will get an error. It's you need to specify a prefix, as we said, because otherwise the two routes will otherwise it will get exposed as root. So what you specify is, for example, a subsystem. Okay, so here we go, and then we do node server. Whoa, what did I do wrong? I did something wrong. Oh, plugin must be a function. Subsystem. Did I write this? No. Must be a function. What did I do wrong? Here. Exports. Come on. Hey. So now what I can do is I can curl and I can check with my subsystem, and it automatically, and it does work. Now let's try one more thing, because, you know, so what happens if I forget, you know, to specify my prefix? Okay, so if I forget to specify my prefix, now subsystem returns not found, and the route gets exposed as slash. However, you know, Fastify has some very strict checks on how things works. So if I specify another slash and another root endpoint, okay, now I get an error during boot. Okay, and it said a method get array declare for root slash. That's very important. Okay. So I got a nice little error in my application, in my system, so that it doesn't really boot. Not that it goes into another rejection, because listen returns a promise, so I need to do catch console log to actually do it properly. And in fact, you can see that there is a big nice error saying method get already declare for root slash. So it actually prevents you from defining the same root twice. Why this is a problem? Because, as I said, the router works as a tree. So there can be only one route that matches any given path. Now, there is a little bit of overlap if you want to do things, for example, with parameters and stuff. But in most cases, it's very strict. So, OK, so demo time is done. I didn't build this alone. As I said, Thomas helped. Actually, Thomas wrote most of it, I would have to say. Fastify is built on the open source principle. Which means that individuals making significant contribution to the project are given to commit access to the repository, and they can contribute as they want. It's very inclusive, and you can actually contribute. We are a very friendly community. If you want to come and help, there is some issues tagged with good first contribution. So you can actually go in and send us PRs, and we help you. We review them. We are kind of a little bit very picky because of performance and other things, but we are actually very good at helping you skill up and be a valuable contributor to the project. There are tech collaborators on Fastify. So as I said, Thomas and myself started this journey back in 2016, but because of this specific approach, we actually grow our community. Now we have 10 awesome maintainers, 10 awesome people that are actually helping out in maintaining this framework. 110 unique contributors. So 110 individuals sent us a PR. I love this. This is a nice sentence, okay? We are not Node Core, which is in the thousands, but still. We did more than 1,800 commits. It's a lot of work, okay? And we squashed them also, so there is probably more in there. 98 versions. We have just released Fastify v2 RC1, so you can check it out. We did some mistakes when we did v1, so we wanted to fix those. However, we didn't want to break everybody, so we did v2 to actually do this. We also have 87 ecosystem plugins, probably 88 at this point, but whatever. 87 ecosystem plugins that you can download and use to do all the disparable, all the things, from Swagger to all your Postgres, MongoDB, all the database adapters are there, but also other stuff. Very, very handy. Note that, you know, most code does not need to go ludicrous speed, so it's perfectly fine to write slow code, okay? Note that you need to decide this early on if you want to do, if you need speed, but most code does not need it. So, you know, take all of this for granted and stuff. So, as I said, I work for this company called Nearform. If you need any help with Node.js, React, JavaScript, whatever, contact us. We have no position open, but you know, go and check out our careers page, and probably there will be some position open sometime soon. So you might want to check us out. We are a full remote company. We are distributed over 24 countries, mostly working remotely. So whatever, it's kind of a big journey. We are 140 people at this point in time. Where is this presentation? This is actually a very good slide, an important slide. This presentation is already available online, and the first URL is where the render version. The second URL is actually the source code. So you can actually check this out. All the code that I've seen and the demos and the benchmark are all in there. So you can check this out and do things, and maybe whatever, help out, or get some links and inspiration. Then thank you for coming and watching my ramblings for almost 40 minutes. I don't know if you're doing any questions. Are we doing any questions? Probably yes. Are there any questions? There is one question. I knew you had a question.
Hello, great talk. How do you defend against malicious contributors now that the cat is out of the bag, so to speak?
So, a couple of things. First of all, we vet very closely all of our dependencies. So we typically check if something is safe to depend on. Most of the dependencies, we maintain them or are from very known and trustable maintainers. Also, we have a Snyk integrated in the system. You should use Snyk, by the way. It's a fantastic company. So that if there is a security vulnerability or something bad happens, we are notified immediately. We also use another tool called Greenkeeper to keep our dependency up to date, so that if a dependency, for example, introduces an unexpected breaking chain that breaks our tests, that actually could be a problem. We also use in all the modules, and every member of the organization needs to have a two-factor authentication on GitHub to publish things. So if you are an open source maintainer, you should enable two-factor authentication on publish, because otherwise you can expose yourself to so many potential problems. So 2FA is king. However, going back to the question, there is everybody is vulnerable to social engineering attacks. So and my friend Dominic Tarr ended up being vulnerable from a very careful, prepared social engineering attack. We typically wait some months before granting anybody in the organization publish rights. Those are the things that are important. So on our modules, and we typically depend on things that implement similar policies. Are there any more questions? There's no more questions, and we are probably on time. So thank you all.